Okay, so today we're going to talk a little bit about how you calculate how much excess there is. You already know in some reactions, when you have two ingredients and a quantity for both ingredients, that one can be the limiting reactant, meaning it produces less of the stuff that you're talking about, like your product. And the other one is considered to be in excess. And now we're going to talk about how you would calculate how much excess there is. So in essence, how much is left over at the end of the reaction after you've used up all of your limiting reactant. The first thing in any Stoic problem, we need a balanced reaction. So for this reaction, we've got calcium chloride reacting with silver nitrate. It's a double replacement reaction where we're going to make calcium nitrate. All nitrates are aqueous, so we know this one's aqueous. Our other product is going to be silver chloride. We're going to balance our reaction. There we go. I also like to write how much we have of all our stuff underneath. So I'm going to go ahead and put that information down here. So it's got 34.67 milliliters of this. They also give us an equality for it, that 1.2 moles is equal to 1 liter of solution. So that'll be helpful. And then for the other one, it gives us that we've got, let's see, we have 45 grams of this guy. Okay, so we're going to do two problems to figure out what our limiting reactant is. So we're going to start with this one. We got 34.67 milliliters of calcium chloride. And we're going to figure out our product, how many grams of precipitate we make. So here we're going to start by going milliliters to liters. And then we're going to go from liters to moles. And I'm going to make sure that I'm writing my stuff, like if it's calcium chloride or silver nitrate or whatever it is, on my fractions so that I can keep track of it. Our first step in stoichiometry is always to start with what we have, so that's what we did here. And then this was our second step, which is to go to moles. It's a little weird that we're going to moles with like milliliters and liters, and but there are lots of different ways to get to moles. The two most common ones are to use the molar mass. In other words, how many, a number from the periodic table in grams is equal to 1 mole, or that we've got 6.02 times 10 to the 23rd particles, like atoms, molecules, ions, is equal to 1 mole. So those are the most common ways to get to moles. After we get to moles, our next step is to use the balanced reaction. We're going to go from 1 mole of calcium chloride to 2 moles of silver chloride. And then our last step is to go to what we want, right? So we did step 3, use the balanced reaction. Our last step is to go to what we want, 1 mole of silver chloride. And then we got to calculate the molar mass. In this case, it's 143.32 grams, just adding up silver and chlorine. And so that was our step 4. And for that step, we used this equality up here, pretty common. And here we get that this makes 12 grams of silver chloride. Okay, why don't you pause the video for a second and do the 45 grams of silver nitrate. And you're going to do the same kind of problem and figure out how many grams of silver chloride you're going to make. Okay, so similar problem. Hopefully you got the same answer that I did. And now we're looking at these two and we can decide, so we can only make 12 grams of silver chloride. We cannot make 38 grams. So our limiting reactant is calcium chloride. That's the one that we ran out of first. And our excess reactant is going to be silver nitrate. So the next thing we're going to do is calculate how much of the excess reactant is used. In this process, we started with 45 grams of our silver nitrate, and we know we didn't use it all up, because had we used it all up, we would have made 38 grams of silver chloride. We know we didn't make 38 grams, we only made 12. So I always like to circle how much we actually made and cross off the one that's like not even a real value, right? Because you can't make 38 grams. Because that reminds me that in this next part, what I want to do is actually start with my answer from the previous part. So I'm going to say, okay, so I made 12 grams of silver chloride, and I'm going to do a stoich problem that gets me back to my excess thing and say, how much of it did I use up? So we're kind of doing a stoich problem backwards. We know that there's 143.32 grams of silver chloride in 1 mole of silver chloride. And we're going backwards. We're going back to our reactant. For every 2 moles of silver chloride, we have 2 moles of silver nitrate. And then we've got our molar mass of silver nitrate. For every 1 mole of silver nitrate, it weighs 169.87 grams. And again, I'm labeling everything. So here I get that this is gonna make or use up 14 grams of silver nitrate. Now remember, I started with 45 grams. This is telling me this is how much I use up to make 12 grams of silver chloride. So then when we're trying to figure out how much excess there is, then we can say, okay, so we started with 45 grams of silver nitrate, right? That was this amount up here. And then we're gonna subtract the 14 grams of silver nitrate we used up, and we'll get how much we have left over. How much we have left over in this case is gonna be 31 grams of silver nitrate. And one of the really important things to watch out for is when you do this last part, your units should match. It should be grams of silver nitrate, grams of silver nitrate. Your answer is going to be grams of silver nitrate because you're asking how much of your excess reactant is left over at the end. So after this reaction happens, you're going to have 31 grams of silver nitrate left. You start with 45, you've only got 31 left. You're not going to have any calcium chloride left, right? Because that's your limiting reactant. It's going to be all gone. And you're going to produce 12 grams of silver chloride. We didn't even worry about calcium nitrate, but we could have figured out how much of that we were going to make as well.